so as for people that are not here, so that they should be able to use it as a resource, because writing all those mathematical jargons here might not have any meaning to them, if there's no proper audio explanation. Okay, so here today we're going to see the intersecting chords, sequence, and tangent, which means we're going to be able to find the angles when two chords intersect. We're going to also try to find angles when two secants intersect. We're also going to find, the angles when two tangents intersect, or when a chord and a tangent intersect, or when a secant and a tangent intersect. Okay, those are things we're going to see today. They are quite very easy, but they only need proper understanding and memorization of some things. Here it's only based on formula. See what you have. See, you only need to detect the part you're looking for, and then to see if they are tangent, and then use the formula that is required. So here, if two secant or chord intersect inside, so as you can see here, this line here, 1, and this sequence here, 2, these two secants here, they intersect inside and form this angle 1 and this angle 2. So since they intersect inside, we're going to say if two secants or chord intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measure of the intersecting arc. What do we mean in essence here? Here it means since these two red secants intersect and inside here, inside the circle, then measure of this angle 1. Let me quickly claim what I'm doing. The measure of this angle 1 this angle 1 here gonna be half of this arc in front of it, AD, plus this arc behind it, BC. Since these two lines intersect here, so then this arc, this angle gonna be half of the sum of this arc and this arc. Simple explanation. And the other, who is here? Yes, I called you multiple times. Maybe you are not beside your your computer, but I marked you since I saw you on this platform here. And then the other angle 2, gonna definitely also be half of the arc, the sum of this arc and the arc behind it. These are the two arcs that intersect these two lines. Okay, so if you're looking for this angle, definitely gonna be the arc AB, half of AB plus DC. So this is an example here. Find measure AED. We're gonna move from A to E to D. That means this angle here. And we know if we call it X, X gonna definitely be equals to, according to the formula, half of the sum of the intersecting arc, according to this statement here, half of the sum. So half means 1/2. The intersecting arcs are this arc in front and then this arc behind it. So it's gonna be 45 plus 109. And when you add 45 to 109, it definitely gives you 154. And then multiplying 154 by half gives us 77 degrees. So the next problem 2, measure of angle STR. We're gonna move from S to T, S to T to R. That's this angle here. The arc in front of it is this, SR, and the arc behind it is this. Then, so these are the one, if you trace these two secants, the intersecting arc is going to be these two arcs are put in red, this and this, according to the angle here. So it means it's going to be, if we call it x again, x is going to definitely be equals to half. The arc in front is SR, which is 112, and the arc behind, which is PQ, and it's in value 186. Then 112 plus 186 is 298. Take half of it. Gonna definitely be 149. Okay. So if two secants meet, or intersect inside the circle, or two chord intersect inside the circle, to find the angle at one of the chords is just take half of, if you find a measure of one of the angles inside, when two secants or two chords intersect, just take half of the sum of the intersecting arcs. The arc behind and the arc in front, take the sum and then divide it by 2. But this time around, here, the first one is about when they intersect inside. What about if they intersect on the circle, which means somewhere around the tangent, okay? So here the rule says, if a secant and a tangent intersect at the point of tangency, then the measure of each angle is, of each angle formed is equal to half the measure of the intersecting arc. These are just statements today that are facts, so you only need to apply them. Which means here, if I want to find measure one here intersect this arc, so it's going to be half of this arc, the arc here. Since A has this arc AB, so it's going to be half of AB in terms of arc, okay? The other one, measure two, and this angle here has this arc that it intersects. So measure two going to be half of arc BCA. When two secants or arc intersect inside a circle, it's going to be the measure of one of the angles at intersection going to be half of the sum of the intersecting arc. But when they intersect, when the secant intersect a tangent at a point of tangency, as you can see here, this line here, I'm going to draw in green, is a tangent line. And the point of tangency is A. And from A, we have another line here, which is a secant that passes through A. And they intersect on the circle. Then to find the angle at each part of the point of contact, we only need to take half of intersecting arc. That's all. And then we also have these problems to solve here. Here, find DEG. DEG, we move from D to E to G. That means from D to E to G, that's this big angle here. And what do we observe? Line, this DF is a tangent line because it touches the circle at E. And then EG is a secant because it passes through the circle. Then here we have intersecting arc on the circle, which means this angle that is formed here is going to be half of this big arc that intersect it. So X here going to be half the arc DHG. And DHG here is definitely this big number, 308. And half of 308 is 154. The other side too, find DB from D to B and then to C. That's this arc here, which means it's going to be half of this angle here. That means it's going to be half of this arc. So we're going to say X, let me call it X, being equals to half, always half of the intersecting arc. The arc is DB. But we don't even have arc DB. So let's find DB. And we also know that DB is equal to, let me clean and put it somewhere far away. DB here is equals to 360. You know, sum of angles on the circle is 360 minus this part. Because putting the orange and the purple gives us 360. So to get the purple, you just do 360 minus the orange, okay? So 360 minus 192, which gives us dB to be equals to 168. Then you go back to the equation you already set, half of 168, which is definitely 84. And another stuff here is when the intersecting arc is outside the circle. The first one, when the intersecting arc is inside the circle, take half of the sum of, if the intersecting, if the intersection is inside the circle, take half of the sum of the intersecting arc. When the intersection is on the circle, take half of the intersecting arc. And then when the intersection is outside the circle, just take half of the difference of the intersecting arc. That's all. So here, if the secant or tangent intersect on the circle, on the outside of the circle, then the measure of the angle formed is definitely half of the difference of the intersecting arcs. So the three things we learned today: when the intersection is happening inside, take half of the sum of the intersecting arc. When it's happening on the circle, just take half of the intersecting arc. And when it's happening outside, take half of the difference. The difference means minus. Do the big arc minus the small arc. Then you divide by 2. But in the case of inside, take the big arc and the arc, the arc in front and the arc behind, add them together and divide by 2. But when it's happening on the circle, the arc that is forming from that angle, just take half of it. So here, these are some visual things here. As you can see, the first case, AC is a secant and the DE is also a secant. So AC, AE are secants, and then they intersect at A. So to get measure of angle A, the best thing to do, the intersecting arc, the big one is here and the small one is here, where they both intersect. So you're gonna take half of the big one, ECE, minus the small one, BD. So these are just formulas, to commit to your memory. When it's outside, take half of the big arc minus the small arc, okay? Here, in this case now, the next case here, as you can see, AB is a tangent because it touches the circle at exactly 1 point. And then AD is a secant because it goes through the circle. Despite that, they still meet outside at A. Since they meet outside at A, you're gonna look at the big arc far away here and the small arc behind here next to the angle formed. Then you take half, the big arc is BD, and the baby arc is BC. And the last one here, we only have two tangents. AB touches the circle at B, and the AC touches the circle at C. So the two of them are tangents. And then if you want to find this angle at A here, the angle outside, as you can see, three of them are always outside here. Then you're going to look at the arc, the big arc that is formed far away, and look at the baby arc. Let me change the color of the baby arc so that we can see better. Because it tends to confuse, especially when two tangents meet. Don't be confused because sometimes you might try to do to name the same arc if you're not careful. So here we're gonna say half. If I say BD for the big one, and this BC for the big one, and the small one is also BC, that means I'm contradicting myself because this angle will be 0 because BC minus BC is 0, half of 0 is 0. So what do I need to do? I need to specify which one exactly. Since the big one, to distinguish between the big one and the small one because they bear the same name, I'm going to add another letter to the big one because big one has D on it. So I'm going to say BDC minus BC. The small one does not have additional letter to it attached to it, okay? Then we're going to solve these problems here and then call it a day. Here we have JL and NL that are secants, okay? And then we want to find the measure of angle KLM. KLM. KLM is the name of an airplane. I think from Netherlands. Yeah, KLM. Air France KLM. So here to find KLM, what do? Since both of them are outside a circle, it means we're going to take the big arc that is formed far away, and then we're going to remove it from the small arc that is formed next to that angle. So if we call this angle X, the KLM equals to X, then it's going to be half of the difference. The yellow one, the big one, is 140, and then the small one is 66. And when you do 140 minus 66, it gives you 74. And what is half of 74? 36. So 37? Yeah, 37. The next one here, we see this is a tangent line, BA, and then this is the secant, DB, and then we are going to find angle STR. No, it's not STR, it's ABC. Angle ABC. I want to find angle ABC, this angle here. We're sorry. ABC. Here we have this arc here, the baby arc, and then we have the big arc. So the angle measure X here, let me call ABC as X, name it X. Gonna be half of the orange arc, which is the big arc that is formed far away. So that will be DB that we don't know, minus the green arc here, which is the small arc formed around that angle, which is 62. Then how do I get the orange arc, the big arc up here? But another thing I know is that the orange arc, the green arc, and this red arc here add up to 360. So to get the orange arc, I'm going to do 360 minus the red minus the green. That equates to 210. That means this angle is 210. Because 210 plus 88 plus 62 is 360, okay? Then I should go back to my initial equation and replace dB by 210. And 210 minus 62 gives me 148. And half of it is definitely 74. The last one here, these two lines here are tangent. They only touch the circle at, one position outside. Then if I want to get this angle, the angle is so close that, it's difficult to see because they are tangent. So here, my big arc here is the whole of this. And this small arc here is this. We have the big arc that is 113, but we don't have the small arc. But we know the big arc and the small arc add up to 360. So to get the small arc, we're going to do 360 minus the big one, 313. And that one gives us 47, which means this arc is 47. Okay. Then we go back to find our x, which is half of the difference between the big and the small. The big is the orange, 313, and the small is the green, 47. And the difference of these two numbers is 266. And if you take half of it, half of 226 is definitely 133. 6 divided by 2, 3. 6 divided by 2, 3. 2 divided by 2, 1. Okay. So this is all we have for ourselves today. To recap, when two either chord or sequence meet inside the circle, then to find the arc at the intersection, just take the half of the sum of the intersecting arc. Look at in front of that angle, the arc that is formed there, and look at behind it, the arc that is formed there, add them together and divide by 2. That's half of the sum. And inside the circle, you will never see a tangent. A tangent does not pass inside through a circle. It only touches the circle from outside. Then if you have intersection on the circle, that means a tangent is involved, because a tangent will always touch the circle at one position. Okay, so if at that position too you have another line that passes through the circle like a secant or a chord, then the point of the angle formed at the intersection will always be half of the arc in front. And lastly, if two lines intersect outside a circle, like in the case, which is possible, two secants can meet outside the circle, which is, in the first visual here. As you can see, both of them meet outside the circle here. Also, a tangent and a secant can meet outside the circle, like in this case, or even two tangents can as well meet outside the circle. If that one occurs, it means to get the angle outside at the intersection, just take half of the difference. The difference means the big arc that is formed far away minus the small arc that is formed next to that angle. The big arc is the orange far away, and the small arc is the green next to that angle. Take the difference. That you subtract big from small. Subtraction means difference. Difference means subtraction, okay? And so, sum means addition. So that's all we have for today. And then let's see what we can do for our homework.